Hello everyone. In this video, I will do some application problems related to the quotient rule of derivatives. So let's take a look at the first problem. So take a moment to pause this video and read the problem and then we can do it together. In this problem, we are given the number n is the number of grams of a compound formed after t seconds, and it's given by this function. We need to find how many grams per second are being formed after 2 seconds, after 4 seconds, or after 6 seconds. So our goal is to find how many grams per second are being formed. So it means we are looking to find the rate of change. And we know that the rate of change means we can find the derivative. So first we can find the derivative function, and then depending on at what time we want to know the rate of change, we can just plug in the values of t. So if we analyze the given function, so we see that this is a function of the form u over v. So we can use our quotient rule for derivative. So using the quotient rule, so sing your song and work along. Low d high minus high d low over the square of what's below. So low is 2t square plus 3. So low d high, so 6t square minus high d low, so 2t square plus 3 over the square of what's below. So 2t square plus 3 as it is. Derivative of 6t square, 12t minus 6t square. So so derivative of 2t square would be 4t plus 0, so only 4t. Whole thing divided by 2t square plus 3 whole square. And in the next step, we're gonna just do some algebraic simplification. So 12 times 2 is 24, so t cube, 36t, and then minus 24 t cube, 2t square plus 3 whole square. And we see that 24t cube and negative 24t cube cancel each other, and this is our rate of change at any time t, but we need to find the rate of change after 2 seconds, 4 seconds, and 6 seconds as per the question. So we just plug in the value of t. So first we're going to find after 2 seconds, so plug in t equals to 2. So this becomes 36 times 2 over 2 square plus 3 and overall square of that. So when we solve it, so we got 72 over 8 plus 3, 11 square, and we got 0.595, so approximately 0.6 grams per second are formed after 2 seconds. Similarly, when t equals to 4 after 4 seconds, so plug in value 4, and you can see that when you do the calculation, you get approximately 0.12 grams per second. Similarly, after 6 seconds, plug in t equal to 6, and you get 2 times 6 square plus 3 whole square, so you get approximately 0.04 grams per second. So this is what we were interested in. So for the same problem, we can do some extensions. So we can ask some few other questions based on this problem. So first question can be, how much compound will be formed as the reaction runs to completion? So this would be a limit question. So reaction runs to completion means the time goes to infinity. So this would be a limit question. So for first one, we will find limit as t approaches to infinity of our function 6t square over 2t square plus 3. So if you try to solve this limit, the first thing we do is we plug in the value of t. So we see that we have infinity over infinity form, which is our indeterminate form. And we learned the trick, like if you have a fractional function, so then we look at the leading term. So in this case, this limit would be same as looking at the leading terms in the numerator and leading term in the denominator. So t square cancels, so this would be equal to limit t approaches to infinity 3, and then it means our limiting value is 3 gram. So 3 gram of compound will be formed as the reaction runs to completion. Another question that we can ask is, what are the units for the rate at which the compound is being formed? So we already discussed in the example that the rate at which the compound is being formed, the units will be grams per second. And the third question is, what is the average rate of formation over the first second? So first second, so it means we can find the average rate of completion. Average rate would be, so change in n, change in the number of compounds over change in time. So delta n over delta t, or in other words, number of compounds at 1 second minus in the beginning over 1 minus 0. So we're going to plug in these values. So from our function, we can find that if you put n1, so t equals to 1, so we get 6 over 2 plus 3, so value is 6 over 5. So if you want to find n0, the value would be 0 over 0 plus 3, which is just 0. So let's plug in these values here. So we get 6 over 5 minus 0 over 1. So we get 6 over 5, which is 1.2 gram per second. So that would be the average over first second. So you can do the different extensions of a problem. So let's do one more example in which we will again use the quotient rule. So take a moment to read this example. So here we are given pressure, volume and temperature of a helium gas sample, and they are related by this relationship. So R is given to be a constant. Our goal is to find dP over dV. So it means our goal is to find the rate of change of pressure with respect to volume. So first step would be, we need to find, since we have dP over dV, it means first we need to find pressure as a function of volume. So first find pressure as a function of volume. So it means from this equation our goal is to isolate P. Isolate P. So in order to isolate P, so we need to bring all other terms on or factors on the other side. So first we get rid of V minus 24. So dividing both sides by V minus 24, we get P plus 3 over V square RT over V minus 24. And then also we only need P on this side, so we get RT over V minus 24. So we subtract 3 over V square on both sides. So now we got our P as a function of V. So now we can take the derivative of P with respect to V, which will give us dP over dV. So now we need to take the derivative of this. So you can do it in different ways. So derivative with respect to V. So if you notice that R is a constant, and also since we are taking derivative with respect to V, so only the denominator is variable. So either we can use our power rule, or we can use our quotient rule, whatever you want to use. And in the second case, we can use our power rule. So I'm just going to rewrite this. So we get, so d over dv of rt over v minus 24 minus d over dv. So 3 you can take out, and v square you can write as v raised to power negative 2. So if we use our quotient rule here, so we see that, so denominator square, denominator as it is, derivative of numerator, so derivative of rt minus rt as it is, derivative of denominator, which is v minus 24. And for the second part we get, so power rule, bring the power down and decrease the power by 1, and we got negative 2 raised to power negative 3. Okay, so v minus 24 and derivative of rt with respect to v would be 0 minus rt. So derivative of v would be 1, and for 24 it will be 0, so just 1 over v minus 24 square minus minus plus 6 times v raised to power negative 3. So in the end we see that we got negative rt over v minus 24 square plus 6 over v cube. So that is our derivative of p with respect to v. And this is what we wanted to find, dp over dv. So that is our desired result. So in this question, we just needed to do some algebra to start the problem. So first we needed to find the function p as a function of v. I hope you enjoyed this video. So in the next video, I'll explain the chain rule for derivatives. So keep watching.